Physics chapter 17, question number 14. Calculate how long it would take a ball to orbit the earth once just above the surface at a speed of 7,920 meters per second, and the radius of the earth has been given as 6,400 kilometers. So this is not exactly a equation question. This is rather a simple arithmetic question. That is, they have given the speed and we have to find out what is the length that it has to travel or the distance that it has to go, and find out how long it is going to take. So the radius has been given. So let's try to figure out what they are asking. So there is the earth is there, and it has a radius of 6,400 kilometers, and this object is traveling at 7,920 meters per second. So they are asking for the time. So that is the question. Now, then to figure out, before we do the question, we need to understand that it is the length that we need to find out, or the distance that it travels. So the distance, that is the length of an orbital. So because this is a circle, it is 2 pi r. So 2 into pi obviously you have to take using the calculator. Then r is going to be 6,400 multiplied by 10 to the power 3, because 6,400 has to be converted into kilometers, meters rather. Kilometers is 6,400 and it has to be converted into meters. So you do this in the calculator. So let's do it. 2 pi and 6,400. So 2 multiplied by pi multiplied by 6,400 into 1000 is equal to 4.02 into 10 to the power 7 here, 10 to the power 7 meters. So the length is 4.02 into 10 to the power 7. Let's round it off to that. Now, but that is not the answer. We have to find out the time it takes. Now, what is the equation for time? Speed equals, what is the equation for speed? Speed equals displacement over time, or rather velocity equals displacement over time. Then time is equal to displacement over velocity. So in this particular situation, the time is what they are asking. We know the displacement. Displacement is 4.02 into 10 to the power 7. This S can be confusing. S is not referred to. S is not the speed, but it is the displacement. 4.02 into 10 to the power 7 is the length that it has traveled. Then it has traveled at a speed of 7,920. You divide it and then you will get the answer. Let's see. So this divided by 7,920 will give us 5,077. 5,077, we can round it off to 5.08 into 10 to the power 3. How about that? Right, 5.08 into 10 to the power 3 seconds. So the answer is 5.08 into 5.08 into 10 to the power 3. What are the units? Seconds. Alright, so that is question number 14. I hope you did that. Then I'm sure you have done question number 15 as well. Let's do that quickly. A stone of mass 0.2 kilograms is whirled round on the end of a string of length 30 centimeters. The string will break when the tension in it exceeds 8 newtons. Calculate the maximum speed at which the stone can be whirled without the string breaking. So what are the details that they have given us? We have to find out. We have to first mark the details that they have given us. So the details that they have given here are, they have given the mass of the stone then the radius of the length of the string will actually give us the radius of the circle. Then the tension or the force has been given. What is the equation that relates these three? The equation is F equals mv squared upon r. So we have to use that. F equals mv squared upon r. Please look back at the equations if you find difficult figuring out which equation to use. Mv squared upon r. Now what do we need? We need v. So what we can do is we can substitute the values and then finally make v the subject, or else we can directly make v the subject. I think it is going to be much easier for you. So what I'm going to do is I'm going to cross multiply, then I will get f into r, then m comes down here is equal to v squared. Then v is going to be the square root of this fr divided by m. I hope you understood that. So now we have an equation. Now we need to substitute the values. Now v equals, I will rewrite it, fr divided by m. V is what we are trying to figure out. F we know. What is f? F is, now they have given the values. The stone of mass 0.2 kilograms whirled around a string of length 30 centimeters, and then they have given the maximum force is 8 newtons. So at 8 newtons, that is the maximum centripetal force. So let's fill in the values. F is then of course 8 newtons, multiplied by r is 30 centimeters. You have to divide it by 100 to make it into meters. So that is going to be 0.3, divided by mass is given as 0.2 kilograms. So you do that. Then 8 into 0.3 is 2.4. 2.4 divided by 0.2 is, you will get the final answer to be 3.46 meters per second. I hope you understood that. If you, that is 8 into 0.3 divided by 0.2, and then you get the square root, you get the final answer to be 3.46. If you have any difficulties, please raise questions. So let's go into the next part of the question. That is question number 16. So these are the type of questions that you might get for your examination. Now, International Space Station, ISS, has a mass of 350 tons and orbits the Earth at an average height of 340 kilometers, where the gravitational acceleration is 8.8 meters per second squared. The radius of the Earth is 6,400 kilometers. So now you need to understand, whenever there is a question and whenever it refers to g, you cannot go ahead and put 9.81 for everything, because the further or the higher up you go into the space, lesser is the gravitational acceleration. So this is a situation of that sort. So the gravitational acceleration has reduced drastically up until 8.8 meters per second squared. So you have to use the values that they have given. And also the Earth's radius, it is to be 6,400 kilometers. But at the same time, this thing is, the ISS is at a height of 340 kilometers above the surface of the Earth. So as a result, you have to add that as well to find out the values, or to do the calculations. Then part A, centripetal force on the space station. Now, to find the centripetal force, what is the primary equation that we have for force? Force equals ma. Now, in this particular situation, we know m and we know a. So then we don't have to go for further advanced or more complex equations. We can directly take it because the details are there already. So 16a is quite easy. We use F equals ma to find out the value of the force that is required. Mass is 350 tons. So you multiply that by 10 to the power 3 to make it into kilometers. I write it down under 350 into 10.3 into 8.8 when you use the calculator, you will get the answer to be 3.1 into 10 to the power 6 newtons. 3.1 into 10 to the power 6, and because this is a force, you are going to get the units in newtons. I hope you understood that. Let's go to the next part. The speed at which it orbits, just like the earlier question, now they are asking for the speed. Once again, we have to get the equation F equals mv squared upon r, because force, mass and radius, they are the ones which are playing a part in here. So we have to use those details. Then when making use of those details, we have to figure out we have to make v the subject, like we did in our earlier question. We can get v to be equal to the square root of fr over m. So you do that. When you do that calculation, once again, if you have any difficulty, please refer to that. But I'm going to directly take the equation v equals fr upon m square root. V equals square root fr upon m. So I'm going to use that value. Now, then what is f in this particular situation? We calculated that, didn't we? In our first part, we calculated it to be 3.1 into 10 to the power 6 newtons. 3.1 into 10 to the power 6 newtons. That has to be multiplied by the radius. Now, you have to be very careful. Radius is not directly 6,400. Why? Because the International Space Station is at a height of 340 kilometers from the surface. So that means you have to add that as well. 6,400 plus 340 is 6,740. And that has to be multiplied by 10 to the power 3 once again. I will write it down under here. 6,740 multiplied by 10 to the power 3. Why? To make it into meters. And then you have to divide this whole thing by what? By the mass. Fr over m. Mass is equal to 350 tons. Then once again that has to be multiplied by 10 to the power 3 as well. Why? To convert tons into kilograms. There are 1000 kilograms in a ton. So you have to multiply it like that. So 3.1 into 10 to the power 6 multiplied by 6,740 into 10 to the power 3 divided by 350 into 10 to the power 3. And when you simplify this, you will get the answer to be 7.7 into 10 to the power 3 meters per second. 7.7 into 10 to the power 3 meters per second. Right. So I hope you understood that. Let's go to the other part. The time taken for each orbit. Time taken for each orbit. Once again, we have to get, we have to calculate the orbital length or the circumference once again. Just like in our earlier situation, you use 2 pi r and find out the circumference. And that circumference has to be divided by the speed. Now speed we have calculated. So let me write that. So the distance it travels is 2 pi r. It has to be divided by the speed. Then 2 pi into r is now once again 6,400 plus 340 into 10 to the power 3. That is 6,740 multiplied by 10 to the power 3. And that has to be divided by what? That has to be divided by the speed. Now speed which we calculated, 7.7 into 10 to the power 3. Now when you simplify this using the calculator, you will get your answer to be 5.5 into 10 to the power 3 seconds. You can, if they ask you to convert this into hours or anything like that, you will have to divide it by 60. 60 into minutes, and then again divided by 60 would give you in hours. Alright, then they are asking as the last part, the number of times it orbits the Earth each day. The number of times it orbits the Earth each day. Now, because I have left it in seconds, I'm going to leave it as seconds. Then what I'm going to do is, in a day, how many seconds are there? 24 is hours into 60 minutes into 60 seconds. And that divided by this 5.5 into 10 to the power 3. Then when you do this, you will get 15.7 would be the answer. So the International Space Station circles or goes around the Earth 15.7 times each day. So that means it sees the sunrise 15 times each day. It sees the sunset 15 times each day. So if you ever become an astronaut, I know you can, if you try, and if you have that desire, you should try. And if you become an astronaut one day, you will be able to see the sunrise 15 times each day, and that would be one marvelous thing. Then let's move to the next question. Question number 17. A stone of mass 0.4 kilograms is whirled round on the end of a string 0.5 meters long. It makes 3 complete revolutions each second. Calculate its speed, its centripetal acceleration, the tension in the string. So now there is a stone of mass 0.4 kilograms. Mass has been given, and then the radius has been given, and they are asking for the for some certain details. Now we can actually from the details they have given, we can find out another thing. That is, we can find out the time for one circle or one revolution or one orbit. We can find out. Why? Because they have given that it does 3 circles each second. So that means we can find out the time for one orbit or one revolution. One revolution is equal to 1 second divided by 3, which is going to be, if you write it in decimal, 0.333. It would take 0.333 seconds. It goes on it goes on for more, but you can actually use this use either 1 upon 3 or 0.333. That would give a more or less a similar value. Now they are asking for the speed, its speed. So let's try to figure out the speed. To find the speed, what is the equation for speed? Speed equals distance upon time, right? Speed equals distance over time. So speed equals distance over time. So now what is distance? Because this is a circle, it is 2 pi r. Divided by time is 0.333. So I'm going to the next page to do the calculation. 2 pi r, 2 into pi into what is r in this particular situation? R has been given as 0.5, wasn't it? 0.5 meters long. So it is 0.5 divided by 0.333. This will give you the answer to be 9.4 meters per second. 9.4 meters per second. Now they are asking for the second part is centripetal acceleration. It's centripetal acceleration. What is the acceleration towards the center? So now what are the values that they have given? They have given the speed and they have given the radius. Have they given anything else? So what are the equations that we can use? You have to be thorough with these equations. You have to know what equations you need to use, right? So now the equations are A equals V omega, A equals V squared upon R. Then also we got A equals omega squared r. Now here we are not referring to omega, therefore we can use the equation A equals v squared upon r. This equation can be used. So now let's use that and see how well we can go ahead. It's centripetal acceleration. Let me go to a new page. The centripetal acceleration once again is going to be A equals v squared upon r. Now we have found v, that is 9.42 squared divided by r is 0.5. So then acceleration will come to be 178 meters per second squared. That is your answer. Right, then let's go to the final part of that question. The tension in the string, or the force. Now, once again, what are the details they have given? Now, we just calculated the acceleration. Then we know the mass also. Then what is the equation? F equals ma. So, F equals ma is used to calculate the centripetal acceleration. Mass is given to be 0.4 multiplied by 178. We just calculated the acceleration and the answer is 71 newtons. So that is the tension in the string. Right, let's go to the next question. Question number 18. Mars orbits the sun once every 687 days at a distance of 2.3 into 10 to the power 11 meters. The Mars orbits the sun every 687 days at a distance of 2.3 into 10 to the power 11 meters. The mass of Mars is 6.4 into 10 to the power 23 kilograms. Calculate its orbital speed. Once again, the 2 pi r story. Speed is equal to distance divided by time. So let's do that once again. Speed equals distance over time. Now distance is 2 pi r, 2 pi multiplied by 2.3 into 10 to the power 11. So that is the distance that it is traveling at. Divided by time is, now you have to get it in seconds. It takes 687 days. You multiply that by 24 to make it into days. Multiply by 60 to make it into minutes, and multiply by another 60 to make it into seconds. Right? Then when you simplify this, you will get 2.43 into 10 to the power 4 meters per second. Right? 2.43 into 10 to the power 4. So you have to, just try to understand what specifically they are asking. Right? You understand what they are asking, and then you have to write down. Always write down the details they have given. It would make it easier for you to figure out which equation to use. Always write. Now, for example, here if they have given A, now let me show it in another sheet. Now let's say they have given A. They have now let's say they have asking A. They have given V, you write the value of V. They have given M, you write the value of M. Right? They have given R, then you write the value of R. So now you know that these are the things that are there, and this is what they are asking. So you have to figure out, you have to find out an equation which contains all these four. That's it. Because if they have not given any other detail, then you might be in a fix. But just imagine these are the obvious details that they have given, but still there is no equation that that has only these four. Then you have to find out whether you can find another value using the values they have given. Then you have to find out what is that value and whether there is another equation which formulates all those 5 things. So like that is the best way to find out the equation that you need to solve the question. Right. Then the next part is they are asking for the centripetal acceleration. Then once again we have what are the details now? We have the velocity, we have the speed, we just calculated that, then we have the radius. Now we need the centripetal acceleration. Then the equation that we need to use is a equals v squared upon r. A equals v squared upon r. Let's use that. A equals v squared upon r. So when we use that, v squared is the value that we just used, 2.43 into 10 to the power 4. That has to be squared then. Divided by r is then 2.3 into 10 to the power 11. Using your calculator, you have to solve this. Then you will get 2.57 into 10 to the power minus 3. 2.57 into 10 to the power minus 3 meters per second squared. So you can see that it is quite some. It is a lesser gravitational force, very less gravitational force there, right? Since very less centripetal acceleration that is there. So now they are going to ask the gravitational force exerted on Mars by the Sun. On Mars by the Sun. So let's try to find that. So now what is the equation? F equals ma. Now what is the mass of Mars? 6.4 into 10 to the power 23. 6.4 into 10 to the power 23, they have given it here. Then what is acceleration? Acceleration towards the, now this is actually centripetal acceleration towards the Sun. That is 2.6 into 10 to the power minus 3. When you simplify this, you will get your answer to be 1.6 into 10 to the power 21 newtons. That is the gravitational force exerted on Mars by the Sun. I hope you understood these questions. If you have any further questions, please raise them. Thank you.